let's start with the second talk of today, which is given by María Luján Ganuza. I hope I didn't butcher your name too much. Actually, she's the speaker from most far away for this summer school. She's from Argentina. She's a professor at the Department of Computer Science and Engineering at Universidad Nacional del Sur in Bahía Blanca. Yeah, sorry. And today she will talk to you about lossless multidimensional visualization. So thank you very much, Lu, for agreeing to give us the talk, and the floor is yours.
Okay, thank you very much. Well, good morning. Thank you so much for being here. I know it's early, and I'm really happy to be here. As Kaka said, I'm from Argentina. It's really far away. I'm here for a short stay in Europe, and I'm really lucky that I was invited to give a talk here. As the title says, I'm going to talk about my recent research topic, that is lossless multidimensional visualization. It's not completely related to bio or med. I'm in the BIS section of this summer school. I'm sorry about that. I hope you enjoy it. But I think that also, as David was saying a few minutes ago, we're talking about visualization, and it's not absolutely related to bio or med, but these techniques can be applied to different data sets, and it's important to know that they are around and that you can use them if you have the data that you want to analyze. Let me tell you a little bit about me. Well, I'm from Argentina. It's really far away. It's in South America. I work in the Big Lab. Big Lab is the research laboratory. It's a research laboratory on visualization and computer graphics. And I worked there since 2006, a long time. We are a really short, at the moment, we are a really short lab. We are around 10 people. And these are our main research topics: visualization, computer graphics, a little bit of computer vision and image processing. And where I mostly work on is visualization and visual analytics, and a little bit of computer graphics, because I'm a professor at the Universidad Nacional del Sur, this National University of the South, the translation, and I'm teaching computer graphics there, and a little bit of object-oriented programming. Well, inside this visualization and visual analytics, that's a really big topic, what I'm working on at the moment is multidimensional visualization, spatial data, and time-oriented data. And specifically working with geological data and also eye-tracking data. What I'm going to talk about today is about eye-tracking data at the end of the talk. And now I will talk about a little bit about some techniques for multidimensional data. I will skip geological data today. Well, when we talk about this multidimensional visualization, I'm sure that you're aware of this, but the problem is that we have a lot of dimensions, sometimes a lot of data, and we want to find visual representations of these big data sets. And these visual representations, sometimes they need to be in a lower space. So you need to map high dimensional spaces to lower dimensional spaces. But we still need to preserve some characteristics of the data. And we want to show our complete data set. That's why this is a problem. And what we want to work on or research is in the development of visualization techniques that allow this reduction from high dimensional data to low dimensional space, preserving these properties. So there is this need for tools to represent this data without loss of information. We want to represent our complete data set. There are a lot of visualization techniques that have been developed for multidimensional data, but not many of them are non-reversible or many of them are non-reversible and lossy. And there are two techniques that are well known, that are parallel coordinates and radial coordinates. I'm sure that you heard about them. And these techniques have been here for a long time and have been widely used and proven to be very useful. They also have some problems. Only to refresh, because I think that you know how parallel coordinates work, but this is important for the next part. We have this car data set. It's a well-known data set that is used a lot in visualization. We have data set about cars, a lot of items, and some information about the cars. We have 7 dimensions in the data set, and in this case, 406 data items. And with parallel coordinates, what we will have is we will have axes, and this axis will be parallel. And the thing is pretty simple, is that we are going to have, or we can have, one axis for each dimension. In this case, if we take the first 6 dimensions, we will have 6 parallel axes. And how do we plot these data items in this axis? Well, let's take the first one. We will take the value for one dimension, for example, economy is 13, and we will plot a point here in this axis, and we will do the same for all the dimensions. And when we want to plot this data item, what we are going to do is to plot a polyline, joining these points. It's quite easy. And the thing is, you can do this with all your data. Then what we are going to do is to overplot polylines. And a lot of work has been done in regarding parallel coordinates. You can have polylines, you can have curves, you can have a lot of different interactions. You can use coloring to differentiate different categories. In this case, we have cylinders as a category. And you continue plotting all your data set until you have something like this. And it's quite interesting because you can have potentially as many axes as you need. And then if you have a data set with 10 dimensions, you can plot your 10 dimensions, 15, 20, 30. But of course, you reach a limit because we have the limitation that is the size of the screen. You can also plot a lot of data items because you draw lines. Perfectly fine. But what's the problem? The problem is that you have too many lines and you are overplotting lines. You will have a clash occlusion. And you can have another arrangements for this axis. If you have a radial arrangement, you have the radial plot that is also well known. Well, these two visualization techniques have been used a lot. I really like them. I use them a lot. And there is, the thing is, there is this need that we need to create, develop, or define new visualization techniques that also allows you to represent the complete data set, to represent a lot of dimensions without losing information. And in this context, these new coordinates appeared some time ago. Boris Kovalarchuk is the author. He presented these GLC coordinates in 2018. GLC is general line coordinates. They are based on the parallel and radial coordinates that we were talking about, but they are quite different. They are really nice. But the thing is, the author presented these coordinates with this idea. You can arrange axes. If you have parallel coordinates, we know about them. We have radial coordinates, but we can have different arrangement of the axis. And with different arrangement of the axis, you get different representations. And these different representations can tell you different information about your data. And it's quite interesting because you have, for the same data set, all these different representations. Some of them are easier to understand. Some of them can get quite complex. the author presented two big groups of general line coordinates. The first one is non-paired general line coordinates. These coordinates are an extension of parallel and radial coordinates. And they work in a similar way. To plot a data item, what you do is you have your axis, and you plot in each axis a point with the value of the attribute associated with that axis, and then you draw lines or curves joining those points. But there is another group of GLC coordinates that is this pair coordinates, and this generalizes Cartesian coordinates. And these are quite different to the other ones. Also, you can have different representations of the same data set. Well, when we started to study these coordinates, they got our attention because we have a lot of multidimensional data, geological data, data derived from age tracking, and a lot of different data. And we started to plot them with these coordinates, and we found some interesting things, because there are some relations between dimensions that were hidden before, and we started to somehow analyze them in these new charts. But they are quite difficult to understand, and they are quite new. So what we did at the beginning, we started doing a survey in the literature, trying to understand if these coordinates are being used at the moment. And what we did is to start with compiling the papers regarding non-pair coordinates, these GLC coordinates that generalize the parallel and radial coordinates. We didn't work, or we didn't start it with the pair coordinates because there are really few papers in the literature, and they were not enough to make a survey. So we started with these pair coordinates, and it was quite interesting what we did. We defined a taxonomy and tried to frame all the papers we researched in this taxonomy. And we took into account several things. And between those things, we took into account interactions. Because, of course, what we realized is there is a lot of work in parallel coordinates, radial coordinates, but these new configurations, like they are quite new, there is not a lot of work done yet. And regarding interactions, there is a lot of work done in parallel coordinates that we think that it's important to somehow extend to the other coordinates. In our study, we realized exactly this. There is a lot of work to be done. And we also realized that there is no, or there was not a library or a tool that can people use to draw these new general line coordinates and to start to use them and to compare them. So we work on this GLCBs that you can download it and use it. It's an open source library that you can use in JavaScript and plot the different GLC, all the GLC coordinates with your own data and integrate it in your web page or your project. And well, you can, for example, represent your data with different GLC representations, and also there is support for interactions. So there are basic interactions that are also implemented there. And if you don't want to code, but you want to analyze your data, we also provided with this GLC exploration tool. There is a link if you want to check it out. There is this web page where you can upload your data and simply through an interface analyze your data with the different GLC representation. And we have this dual view that is linked. So if you understand, for example, parallel coordinates and you want to check what is going on with your data with other coordinates, you can see both of them at the same time. And through using some interactions, you will understand somehow how this works. We think that this is really interesting because if we think that these new GLC coordinates have potential for analyzing data, it's important that there are tools out there that people can use and the visualization community can use to explore them, to analyze their potential. And here I have 2 examples because I know that all these visualizations are like maybe a lot. Here we have an example. It's a synthetic data set. This is parallel coordinates. We are quite used to it. We have 5 classes here. And we can see that in parallel coordinates, we have this representation. We can see, as we are using coloring to differentiate the different classes, here we have the different groups. We can differentiate them. There is some overplotting here between class 5 and 3. But here we have another GLC representation that is called collocated per coordinates. And in this case, the same data set is represented in a completely different way. And here we can see these clusters completely separated. And here we have another GLC coordinate that is called shift per coordinate. And in this case, we have all lines and all completely overflowed. So the thing is, there is not, in this case, this representation is better if we want to somehow differentiate the clusters, but it doesn't mean that this is the best representation. It depends on the task, what you are doing, the data set, and a lot of things. And here you have another example. We have another synthetic data sets. Here in parallel coordinates, we can see these 2 differentiated groups, but in these collocated per coordinates, they are represented as circles. And in radial coordinates, we have this representation, and this collocated radial coordinates, this different representation. And I think it's quite interesting how we get different views of our data. Of course, there is a lot of work to be done. We need to understand how, not how they work, but how can we extract all the potential these coordinates have, and to work on the interactions of these new coordinates, because we have a lot of work done in parallel coordinates, but we have to see if this work can be extended to the other coordinates. And I want to talk to you about another project. It's also related with multidimensional visualization, but not with GLC visualization. And it's about visual analysis of eye movements during microstory reading. This seems completely different, but it's not that different. I will talk to you about it. The thing is, we are interested in analyzing how people read. Why? Because reading is a really complex task and gives you a lot of information about the cognitive process. And can tell you if you are a neuroscientist, I cannot tell you, but it can gives you information about if you may have any problem with your short-term memory, if you're having any cognitive problem, because it's like people read in a certain way. Not everybody reads in the same way. That's not a problem in most of the cases, but there are some things that can tell you that maybe something is happening, it can be a problem or not. How can we analyze how people read? Well, scientists have embraced the use of eye trackers. I'm sure you know what an eye tracker is. It is a device that can measure where are you looking at in a moment, and it gives you a lot of information. It tracks where your eyes are looking at over a stimulus, in this case, a text, and it gives you information. How much time did you spend looking at some point? How fast are you moving your eyes? How is your pupil? Is big? Is it small? And you can derive a lot of information from that. And Well, here is a screenshot of the eye tracking device. And the thing is, when you are reading, you are doing fixations. Fixations is these locations where the reader pay the most attention and stays there for a while. And then you have saccades. Saccades are the transitions between these fixations. If you can track, if you can track the fixations and the saccades, you can track the path that the reader follows when he's reading something. And the thing is that you can fixate on some part of a word, for example, then do a saccade, fixate. And not all the saccades are forward. You can also come back at some point. And this is what is called a regression. All of us, well, I'm not sure if all of us, but many of us, when we read, we do regressions. It's something that is natural. But if you do a lot of regressions, maybe you are having a problem, you are forgetting, or you are not paying attention, okay? And this is what we are trying to analyze. There is a concept in eye tracking that is area of interest. And it depends on the stimulus that you are analyzing. If you are tracking someone watching a picture, for example, an area, and this is a face in this picture, an area of interest can be the eyes or the nose or the wherever. But when we are reading, the areas of interest are the words. So when we are talking about, when I say area of interest or AOE, I'm talking about words. And when you fixate, you fixate in different parts of a word. And you don't fixate in every word. We are skipping words. And we are focusing in reading, but a particular type of text that is micro stories or short text, short fictions. This is an example in English, but our examples are not in English because we don't have native English readers or speakers in Argentina. So the examples that you will see are in Spanish, but well, I wanted to give you an example in English. I really like these short stories. I think they are really clever. And the thing is, they are quite popular right now because we are writing all the time short text and reading short text. And the microfiction is characterized by two main characteristics. The first one is short, and it depends on the language. In Spanish, for example, we say that a microstory is up to 140 words. And it's efficient because it makes a really good use of language to tell you a story in a very one sentence or two sentences or three sentences the most. And we like them because when you read a micro story, you need to pay a lot of attention for a really short period of time to understand it. Well, so we have this microfiction, we have the eye tracker, we have people reading the microfiction, and from the eye tracker, we get a lot of information. And the question is, from all this information, what do I need to analyze and what is important? For this, we have an expert in neurosciences and experts in eye tracker, because I'm from the visualization field, so I don't know anything about it. But the thing is, with the help of these people and reading a lot, we realize that there are some things that are really important to take into account. First, the variability of the fixation and saccades reflects the cognitive processes associated with understanding a text. This means that skilled readers will exceed short fixations, durations, longer saccades, and fewer regressions. It means that if you are a skilled reader, you will stay a short period of time in each word. You will have longer saccades. It means that you are skipping a lot of words, and you are not coming back too much. Also, pupil dynamic and fixations are sensitive to mental workload. It means that if you are staying too long on a fixation, it means, or it can be related to the level of cognitive processing. It means that maybe you are staying there too long because you are processing, trying to understand something. You can also stay there too long because you are thinking about something else, okay? And the pupil dilates when the cognitive effort is higher, when the task that you are doing is higher. So if you are reading and your pupil dilates, maybe you are making an effort to understand. Also, dwell time reflects integrative processing. Dwell time is the total amount of time that you spend on one word. And the thing is, readers dwell longer at sentence boundaries. Because this, for example, if you are reading a short text, when you get to the end of a sentence, maybe you are staying there for a little bit, trying to integrate what you just read before going to the next sentence. And this is some of the characteristics, and also the characteristics of the text that you are reading are important. For example, the length of the word, the predictability of the word, the frequency of the word. What I want to tell you with all this is that we have a lot of characteristics that are interesting. We have this table that we publish in this work with all the important characteristics that we should analyze for reading of micro stories or short fiction. And what we did is to propose this visualization technique to analyze all these characteristics. The thing is, we have two linked views. The stimulus here, because we want to know the micro story and how the user was reading it. This is presented exactly in the same way as the user was reading it. And this radial chart. And in this radial chart, we condense a lot of information that will tell you about this. We have the micro story here in this analysis. And each sector of this ring contains a word, and the size of this sector is related to the length of the word. And we use this texture to indicate which words the reader skipped. And we also have some filters here, and I will tell you about this in this way because maybe it's better. So we have the word and sentence analysis, because the words are here and the sentence are in this inner analysis. I don't know, in this case, this micro story has only one sentence. So here we have the words. The radar chart in the middle, we use it to represent time. So here you have a radial axis, and in this radial axis, we're representing how long the user stayed on each word. Then you have the transition spiral, this one. And this transition, each of these segments is a transition between words. So this user skipped the first word, start here, made this transition. And we have different colors for transitions because we have a transition intra-word and inter-word. Inter-word is when the user is transitioning, doing two fixations in the same word. And the other one is when it's doing transitions between different words. And we have the regressions here. When the user changes the direction of the reading, in this case, what we are doing is increasing in one step the radius of this spiral. So if you have a reader that is going back a lot, you will have this spiral getting bigger and bigger and bigger. And we have another spiral that is inside that represents the pupil diameter. So you have in these circles fixations, and the color indicates how big or small the pupil is. So if you see that in this case, it is bigger at the beginning and then started to get smaller and then bigger and then smaller and then bigger. And all of this is linked with this view. So we have a lot of interactions to analyze this data. And the thing is, if you, for example, select a word here, this word will be highlighted also here, and you can get a sense of in which part of the text you are, which part of the text we are analyzing. So we have interactions over transitions. If you put the mouse over the transition, you will see information about the transition. In this case, this transition goes from the word end to the word phantasma. End is in, phantasma is ghost. It doesn't matter. And if you click on a particular transition, you will get information about the words associated with this transition and also the time spent on these words regarding this transition. And also it will be highlighted in the stimulus. So this also happens when you click over a word. You have more information about this word in particular. And also here, for example, you click over this word and all transitions associated with these words are highlighted. Also the other words associating with the transitions are highlighted. And here you also have information. And in the stimulus view. And you also have filters. So you can filter if you want to see only saccades that have certain amplitude, angle, etc. So with all this information, the analysts, the people who is interested in this data, that are neuroscientists, started to analyze, and I want to show you 3 examples of what they saw here, because it's quite a lot, or you can see that it's quite a lot. And for example, one of the questions that these experts wanted to answer is, as the microstory requires the reader's utmost attention, is it possible to appreciate this cognitive overload from eye movements and pupil behavior? What they wanted to see if they could realize in which part of the story the user was making the most effort. Or on another words, it's which part of the story is the most important or the most complicated part of the story. So they started analyzing the pupil diameter. And they realized, well, in this case in particular, for this user in particular, this guy started with a small pupil diameter, and at some point it started to increase, and then it went smaller again. So maybe something is happening here. But that's not enough. It's not that you check the pupil diameter and that's it. So you have to see what's going on with the other characteristics. So these experts analyzed the regressions, and they have one regression here. Here you have another regression. Here it's coming back, and here a lot of regressions. So they were interested in this part because why this guy is reading in certain way that is not coming back, and at some point of the story it's coming back a lot. So here they realize that when you select these interactions, you realize that the dwell time, the time that the reader spent on this word, is bigger. So somehow this can tell the expert that the reader here is taking too long, or not too long, but a longer time in his word, coming back a lot, and also the diameter is bigger, so they can somehow understand that this is like the most complicated part of the microstory. They also interested in realize if it's possible to visualize, to visually detect the moments where the reader integrates the text. And I was telling you a little bit earlier that you can check if, or you can see that someone is integrating the text if they are dwelling longer at the end of the sentences. So here, for example, you have a microstory with 2 sentences. There is a dot. So this is one sentence and another sentence. And experts can select this last part of the sentence and realize that the user is dwelling longer there. And the same happened. No, I don't know. Here, I'm sorry. And the same happened at the end of the sentence. And I think here also in the first sentence, the reader is coming back, and is coming back for a really short saccade. So this also tells you that the reader is integrating information and coming back a little bit to finish understanding what he is reading before going to the next sentence. And something that can also be interesting is to analyze the frequency of the word in the language that you are reading. Because here you have another example, and we have some regressions. And in this case, this reader is showing like a different behavior, because it's having like long, really long, I don't know if you can see it here, really long regressions. From this word, it's coming back to this word. And the experts were thinking, what's the problem? Because this reader is showing only 2 regressions and very, very long. So they thought maybe it's related to a difficult word, a word that is not often used in the language or something like that. So we can also provide this with coloring, this information about how, about the frequency of the word in the language. And in this case, the associated words are not like the most frequent word in the language. So that can give you some information. But also, when you select them and you check the stimulus view, you can also see that in both regressions, in this case, the user is coming back from these words to this word, and in this case, from this word to this word. And in both cases, they were located in the same positions for the user, but in a lower line in the stimulus. So somehow this guy is reading until here and like going up, like this and continue reading. And in this case, it's exactly the same, going up and continue reading. So this is like a curious behavior. In this visual analysis of 8 movements for reading, there is a lot to be done. Now we are working with sentences, also with microfiction. We are continue working with this by trying to compare a lot of users, because when we started with this was in 2020, and we performed some case studies and COVID started, so we had to stop. And we didn't manage to have that many user studies, because what we wanted to do at first is to analyze a lot of users and try to find patterns. For example, people that is under 18 are reading this way, and people from 18 to 40 this way, or whatever. And this is what we are doing now, trying to compare a lot of users. We also are working with sentences and with a lot of ideas to continue with this. I'm about to finish. This is something that is also visualization, also multidimensional visualization, but it's a project that I wanted to tell you about because it's online and you can use it. It's a web dynamic dashboard for data visualization. It has a lot of traditional techniques that you can use. You don't have to code anything. You only have to log in there, upload your data, and use this dashboard. So if you have data or at some point you need to visualize something, or you only want to try it, be my guest and write me if you need help or you find bugs. That I always say you will. That's it from my side. Thank you very much for being here. And please, if you have any questions.
Yeah, okay. Thank you, Luján, for a very nice talk. And I already see there are questions, so let's move on.
Thank you very much for the captivating presentation regarding the new presentation of multidimensional data. And I have a question regarding the GLC coordinates software or the underlying procedures. You mentioned before that there already exists a JavaScript version free to use. and because there might be other software, something like RStudio or ggplot2. Is there something in the works, or does it already exist?
I'm not familiar with this software you told me, but I'm sure. What's the name? Sorry, ggplot.
ggplot2.
GDplot.
ggplot.
ggplot. Sorry. I'm not sure. The thing is, I'm not sure. Is that a low-level programming? Is that library or is it a software?
It is a library.
A library. Well, I'm not familiar with that, so I don't know. Maybe you can have this same, you can get this representation with the library. For example, with D3, for example, of course you can. The thing is you have to program it. What we are providing here is a library where it's like another layer, so you can easily plot this coordinate. But of course, if you have other libraries, you can also program it and have your representations, of course.
And going to the next question, the last slide you presented with the dashboard view with the different visualizations. Yes, exactly. In the case we would upload a data set and see, okay, I like, for example, the representation B or L, something. Is it actually planned, or is it a feature to give the user the code snippet used for making said representation?
No, at the moment. No, at the moment. No, but you can ask me. But no, at the moment. It's not like you get there and you can have the code snippet. No.
Okay. And regarding the circular representation with the microstories, the segments used for each word, do they depend on the concentration duration or the word length? Because I've seen that some words have at the end of a sentence and still get, let's say, more screen real estate.
You mean these segments?
Yes, yes.
These are related. These are associated the length of the segment with the length of the word.
Mhm.
In all cases.
Okay. And regarding the pupil dilation,
Yes.
would it also be feasible to include the time points where the tested person has blinked? Because I would imagine that would also correlate to the pupil dilation factor.
Yes. That would be really interesting. We're not doing it at the moment, but yes, we're right. And I mean, you can get that information from the eye tracker. You will have to process everything. And yes, it's something that we have in mind also.
Cool.
Quite interesting, yes.
Thanks very much.
Thank you.
Thank you for the questions. We have some more. So
Thank you for the interesting talk. I have a question about the eye tracking this. So is this analysis based on one sentence?
One sentence?
Yeah, for example, now the circular.
This at the moment?
Yeah.
These are one sentence or two sentences, they're micro story. We have a limit with size. That's why we are also using this radial layout, because if we have longer stories, like a novel, there is no way to represent it in this radial stuff. We can have one sentence or maybe two or three, but we are not having like 10 sentences because we are limited with these micro stories.
Okay.
And that's why we are doing this radial layout.
Yeah, thank you.
yeah, there is one more question.
So thank you for the talk. I really also appreciate the tools that you mentioned in the presentation. And I would have one question. You mentioned that the library you did was for JavaScript.
Yes.
Do you know whether there are any similar things also for Python? I know that Python is not really used in visual research, but for the data analysis, it's convenient to have it like in one place.
I'm not sure because I don't use Python. But I think it's being used a lot now in visualization. So maybe there is a library. I'm sorry, but I don't know.
Maybe I can fill in for Python. There is this Plotly library and extension dash, which enables you to build interactive applications based on the Plotly graphing libraries. So you can take a look into that because it's quite extensive actually nowadays. I'm not sure if you'll find everything at the same level as this was presented here, but yeah, for Python, definitely check out the Plotly.
Thank you.
Okay, do we have any? Yes, we do. So your talk really sparked some interest in people, which is really nice. Go ahead.
What is your opinion on using time for multidimensional data? Like, for example, in the cast data set, you could have a subset of, for example, for the cylinders, and then have one cylinder type, then the next one, then the next one. So you can see the differences between them better.
I'm sorry, but I didn't get the first line of using time.
Yeah, generally using times or transitions and so on.
I don't know if I got your question, but if your data is related to time, I mean, it's time oriented. That's a question.
No, I mean, for example, in the cast data set, you can use the time of the user viewing the visualization. So you have
yes, you mean because I had this axis with time, and again, sorry.
no, I mean that if I view a visualization, the visualization can be a still, just like a photo, but it can also have transitions in them to show it in for 1 second, one subset of the data set, and the next subset, and the next.
Now I got it. I'm sorry. My bad. I really like when you have transitions in animation. I'm aware that this is not always useful. But I think that, for example, when you use animation for time, sometimes it's really useful and sometimes it became a mess. So I think it depends on the task, on the data, and on the visualization. In this case, with parallel coordinates, I'm not sure if your task is to analyze what's going on across time. You can have an animation, and you can have like transitions, like show me what happened at this moment of the time, and the next, and you will see how everything changed according to that. That's amazing, but I think that should be your goal. But if your goal is not related to showing how things are transitioning over time, maybe that can mess a little bit the things. So I'm a really fan of animations and transitions, but I don't know. It depends on the task and the data set when to use it. That was the question? Cool.
Yes, thank you. And I was thinking, for example, then the eye tracker example that is here, there is also a time built into the data because the person was reading in a time. So you could, for example, have it go at the speed around that the reader was reading it.
Yes, we are in this case representing time with these spirals and also using color. I didn't mention that because it's not like visible in this, but the color is fading out with time. And also, I'm always thinking about other ways of representing time. So, and I really appreciate this animation or transition. So I don't know, maybe next time, yes.
Thank you.
Thank you.
Okay. Thank you for your questions. Any more questions for Lu? I think Honza had one.
Oh, thank you very much for the great talk. I was just wondering, at the beginning you showed us this alternative organization of parallel coordinates. I was actually wondering how intuitive or how easy is interpret these axes if we put them kind of in the ordinary places.
It's not that easy. No, it's not that easy. Oh, I'm sorry. I'm going back. Here. These ones?
Yeah, for example.
These ones, from my point of view, these ones are not that difficult because they are, they are like parallel coordinates, but with different layouts. So for example, here you have the same axis, but with some angles. These are quite different because in this case, the representation is made up in a different way. And here you have this other arrangement or whatever. So these non-pair coordinates, I think they are not as easy as parallel coordinates, but they have some similarities. But these ones are completely different.
Exactly. And if you go like a few more slides in front, there was like this one more. Go ahead. There was this image with the circular ones. Go ahead. One more. Forward. This one, right? I mean, having the image on top, I can kind of easily understand the meaning of the axis. But now in the bottom one, I nicely separate the data set, but the axes are harder to understand, in my opinion.
No, because you're right, and I didn't explain it because it's quite difficult. But the thing is, this collocated in this case and in this case, they are representing the data with the half amount of axes. And this is quite difficult to understand. You have to do the draw, and I can show you. But the thing is, here you have 41 axes, but here you have 20 axes. And how does this work? Well, they are combining axes, and it's not quite easy to understand. But we think that it has a lot of potential, and if you start analyzing this kind of data, you will start to see some patterns. And something I forget to say is that they are quite different, but in parallel coordinates, there are some patterns that we are used to see, like positive trends on peaks or we go mountains or wherever. And we would like to see if there are something like that in these others coordinates. But of course, we don't know yet. And you are right, it's quite complicated.
Cool, thank you.
You're welcome.
Okay, then if there are no more questions, then let's thank Lou once again. And
Thank you very much.